Welcome to video lesson 6.5, where we are going to be talking about our properties that we learned a couple of lessons ago and how to use them and apply them when problem solving. You have one green sheet that you just need to trim down and glue into page 75. Please fill out your table of contents, which is applying properties. Just a couple of things that I want to just mention before we get directly to our notes. An equivalent expression is something that we're going to see in class tomorrow when we're practicing this, and that is when there are two expressions that are equal to each other because they have the same value. You saw that as you were working through some of your property practice. Two expressions equal, equivalent expressions. We need today to think about which property is making those two expressions the same. And so that's the application part of this lesson, using properties to prove that two expressions are the same. Now we're going to talk about the first bullet point in your notes. And we are going to be using the symbols equal and not equal to show whether the expressions are the same or not. So here we have some expressions that are not the same. So let's just humor me for a minute. And these two expressions are obviously the same. So you can draw your own two emojis and whether they are equal or not at the top, very top of this page. So the directions of these first examples are the same. We're going to determine whether two expressions are equivalent. So that's a yes, they are equivalent, or that's a no, they're not equivalent. If they are, we're going to tell which property is applied or used to show that they're the same. If they're not the same, we're going to explain why. So here's the first one. We have to look at this expression on the left. They separate them with an and now this is another expression over here. So we have to look and see what's different and what's the same. I'm noticing there's a 15, 5, and 8. 15, 5, and 8. The only thing different between the two are the parentheses. The parentheses are grouping the second and third number, and then they're grouping the first and second number. That is the associative property. So I could also do the math to find out if they are the same. Let's do the math to see if they're the same. If I add 5 and 8, that's 13. And when I add 15, that's 28. Let's add 15 and 5, that's easy, 20. And then I add an 8, which is 28. So my answer to the question is yes, they are equal because of the associative property. 28 is equal to 28. Example 2, let's look at now. We have the 20, the 12, and the 3, and then we have a 20, a 12, and a 3. It looks exactly like the first example, but we're subtracting. And if you remember, the associative property, when you group numbers and you're subtracting, I don't think it's going to work out. So let's test this. 20 minus 12 is 8. 8 minus 3 is 5. Let's go over here and do the 12 minus 3 first, which is 9. 20 minus 9 is 11. So 5 is not equal to 11. So our answer is going to be no, they are not equivalent. Here's our symbol. So the explanation of why, if it does not equal, is just literally that 5 is not the same as 11. Let's move on to example 3. We have 34 plus 0 and 34. 34 plus 0 is just going to be 34, and we don't have to do anything for the second expression. It's just a number. So we have 34 equals 34. Yes, these are equivalent expressions. Which property has a number, adds something to it, and it doesn't change the identity? It's the identity property. That's as simple as that for that one. Example 4, same thing. We're going to determine if these are the same or not. I'm looking at what's the same and what's different. I have a 20 and a 5, and then a 5 and a 20. It looks like it's the commutative property where you just change the order, but we're dividing. 20 divided by 5 is 4, but 5 divided by 20 is a fraction. These two are not equal to each other. This is actually the same thing as 1/4, and 4 is not the same as 1/4. So we're going to answer no, they are not the same, because 4 does not equal 1/4. And remember, the commutative and associative properties, examples 2 and 4 in our notes, did not work because it does not work with subtraction and division as operations, and we just proved it. Example 5 is something that you might see tomorrow as well. It's more of a word problem, but it tells us what to do within the word problem. So it says that Brandy earned $7 babysitting, there she is, and $12 cleaning out the garage. Oh, what fun. Write 2 equivalent expressions. This is the direction here. We're going to write 2 expressions using the commutative property. It even tells us which property to use that can be used to find the total amount she earned. So that total means we're going to be combining our amounts, and we need 2 different ways to write it. Commutative means doesn't matter which number comes first. We could do the $7 plus $12, or we could switch it around and have the $12 first and then the $7. Does not matter. That's as simple as it goes for that one. Now we're going to go up to the top of our note sheet and fill in that second bullet. I didn't forget about it. It's going to happen right now. So why are we talking about properties again and applying it? Well, using properties can make it easier to simplify expressions and to solve problems. So we're going to be seeing different situations and problems, and we can manipulate the numbers, move the numbers around, or group the numbers in certain ways to make the math a little bit easier for us and able to do in our head without having to scratch it out on the side. But that's the major point about why are we even talking about these properties. It's for your good, to make your lives a little easier when you're trying to solve problems. So because this is the main point of why we're applying properties to help us solve problems, draw a question mark in the upper right-hand corner and a light bulb in the lower right-hand corner of your page, to the best of your ability, of course. So we're going to do a few more examples to show you why using properties is useful in solving problems. So here we have a problem. We have a picture of a slide that makes a triangle. The area of a triangle can be found using the expression 1/2 BH. Now these are just a fraction, a variable, and a variable all smushed together. When you see 2 variables or a number and a variable, what is the glue holding them together? Multiplication. So this is the expression 1/2 times B times H, where B is the bottom, the base, and H is how tall it is, the height of the triangle. Then it goes ahead and tells us what B is equal to and H is equal to. We see it in the picture as well, and we have to find the triangle's area. This is a pluck and plot problem, essentially. So let's go ahead and write down the expression first. And now we're going to pluck and plot. B is equal to 15. I'm going to put them in parentheses, and I'm going to put the 12 in parentheses. Now here's where a property comes into play. I could take a 1/2 and multiply it by 15, and then whatever this answer is, multiply it by 12. But if I know about the commutative property, I can switch some numbers around to make it easier for my brain. I'd rather take 1/2 of an even number, because I can split it evenly. So I'm going to move the 12 and the 15 around using the commutative property. So now I'm going to have 1/2 of 12 and then multiply it by 15. So I just used the commutative property to help me figure this out better in my head. So 1/2 of 12 is 6. And then now I just have to multiply 6 times 15, which is 90. So the commutative property helped us move the numbers around so that we can do the math easier in our head. We didn't have to find 1/2 of 15 and then multiply it by 12. Could we have? Absolutely, but it makes our lives a little bit easier. Go ahead and draw a star on the left bottom corner. Our last two examples on the bottom are asking us to use properties to rewrite these expressions so that there's no more parentheses. Essentially, what we're doing is we're making it a little bit simpler, only to a certain extent, because these expressions actually have variables in them, and we're not at this point given what the variables are, like x equals 3 and asked to solve it. That's not the direction. Instead, we have to just manipulate the parentheses so that we can get rid of them using properties. So if you look at example 7, I have an x and a 3 grouped together and a 6. The problem is I don't know what the x is. I don't know what the x value is. So I'm going to use the associative property, and I'm going to leave this x alone, and I'm going to change the parentheses to be around the numbers that I know. I can add a 3 and a 6, and that's 9. So I've used the associative property, and now I can get rid of that parenthesis altogether because I can add those numbers up. So this is called simplifying an expression down. Now we don't have 3 terms, now we only have 2 terms. Let's try example 8. Example 8, we have a 9 times a t times a 2, but the parentheses are telling us that we have to do this first. Well, if we know the commutative property, we can say, hey, it doesn't matter what we do, we can change the order around. So we're going to say t times 9 is the same as 9 times t. And I'm just going to move this down. So we just use the commutative property to rotate inside the parentheses. Next, we're going to do the same thing we did over here. We're going to move the parentheses so that I can take what I know, the 9 and the 2, and multiply that, because the associative property tells us that we can move parentheses around and it doesn't change the value of the expression. So this is the associative property. Now I can multiply the 9 and the 2, that's 18. And whatever this t ends up being, that's great. We're going to pluck and plop maybe later. And I know that we have an expression that's a lot simpler than what we started with. So we use 2 properties here to change it from having 3 terms down to 2 terms. So that's it. We will practice applying properties tomorrow. So I look forward to seeing you then. Have a great night. Bye.